Okay, so welcome to class. Today we are learning about hypothesis formulation. Hypothesis formulation. So we are going to learn how to formulate hypotheses, and also we are going to demonstrate with examples and go on afterward to uh, learn one method of inferential statistics, and that will be Chi-square method. So those are the few things we are learning today. The first aspect is the hypothesis formulation. We want to remember that in research, we need to formulate hypotheses. Excuse me. We need to formulate hypotheses. Now, first of all, we want to know what actually is hypothesis. Hypothesis is a kind of gesture, a kind of conjecture, a kind of guess, an informed guess about a particular variable, how it's being affected by another variable. Then you make a guess that this should be the effect of this variable over this, and this should not be the effect. So it's a guess, and your statistical analysis, your research analysis will confirm whether you are right or wrong. So that is hypothesis. So we are learning how to formulate hypothesis and how to test the hypothesis. So today is for hypothesis formulation and testing. Formulating hypothesis and testing it. So welcome to class. If you are here, just say yes if you can hear me. If you can hear me, just say yes. Type yes onto the chat box. Say yes. If you can hear me, just type yes. And don't forget to like this video. Click the thumbs up so as to like this video. Click the thumbs up. Alright, so I can see your yes. Or Joshua is saying yes. So don't forget to click like. Click the thumbs up to like this video. So we start gradually, expecting others to join, and today we will be able to also know those that came to join by taking attendance. We're going to take attendance of this lecture. Right, so you need to invite others by sharing the link to them. Invite others and share the link to them, and click like on this live lecture. Click like, give us the thumbs up. So as I was saying, we are learning about the hypothesis formulation and testing. In research, we carry out scientific observation of what is happening in our environment. You observe the environment around you. Then from there, you obtain certain information in form of data. When you obtain this information, you look at the information you have and look at variables you have, and then you make a guess that a variable can have an impact, a significant impact on another variable. And that observation will be proven right or wrong by the time you make your guess and carry out a research analysis by means of inferential statistics. Then you come out to make a conclusion about the assumption you made, which is the hypothesis. Hypothesis is an assumption. You assume that this should be happening by observing what you see in the data collected. Now, your test will prove you right or wrong. And that is what we are learning today, how to formulate hypothesis and how to test it. Alright, formulating hypothesis and testing hypothesis. That is what we came here to learn. Now, both qualitative and quantitative data in research involve formulating a hypothesis. I want you to know that. And also, formulating hypothesis is based on scientific method. We don't just formulate a hypothesis. Excuse me. We formulate hypotheses based on the scientific method in research. And the scientific method includes 1. Asking a question. 2. Research existing sources. 1 is asking a question, ask a question. And 2, you research the existing sources. Research the existing sources. No? Research the existing sources, then formulate the hypothesis. Number 3 is to formulate hypothesis. Formulate hypothesis. After formulating a hypothesis, then the next thing is to try and test your design and conduct your study, then make conclusions and then report the results. Design the study, design and conduct the study. Design and conduct the study. Design and conduct the study. Then make your conclusion. Make your conclusion. Now your conclusion is based on the hypothesis you formulated. It's based on number 3. You are making conclusion on your hypothesis. You will soon see what we mean by that. Then you now report. You make a report of what you have seen. You report the results. Okay. So those are the 5 steps involved in conducting a research. So don't forget to like and share the video. Like the video and share it. HLC, I expect that the class rep, be taking notes of the attendance of people connected to this lecture this evening. It's important to us. That is very important to us. So that is why you need to invite others to join this class. Okay. All right. Now, statistical analysis are employed when you have research that's having descriptive purpose, or that you need to draw an inference from the data you collected. So we need to carry out a statistical data analysis. Now, the statistical tests can be used to examine a variety of relationship between data. All right? And then when you are formulating hypotheses, when you observe the data you have, you are going to formulate 2 hypotheses. That is a null hypothesis and the alternative hypothesis. So there must be a null hypothesis and there must be an alternative hypothesis. Then after that, you carry out your inferential statistics. Now, based on particular level of significance, based on a particular level of significance, which is usually 5%. It could be 1%, it could be 10%, but usually we use 5%. Now, based on that, you now check the standard table, the values on the table compared to the values you obtained from your own statistical analysis based on your calculation. Then you make a conclusion. You make a conclusion. And like we know, data can either be qualitative or quantitative. Either you have quantitative data or qualitative data. Quantitative data has to do with data that has a numerical value, numbers presented. For instance, you are dealing with age of people, you are dealing with a length of period, or you are dealing with a time in seconds or in minutes, or you are dealing with the examination scores or a grade point average of students, that is GPA. So we are talking about quantitative data, measurement that you have recorded in numbers. But qualitative data, you don't have such. You only have certain items, certain elements of the research that you're focusing on, which are not in numbers, which are not provided or presented in numbers. Now, formulating a hypothesis. In formulating your hypothesis, what you are trying to do is to predict relationship between set of variables. You are predicting what is happening between one variable or another. Okay, you are predicting what can happen or what is actually happening. So you now take measurements and look at the measurement you have to predict or to make your guess that this should be happening between these two sets of variables. All right. Now, a hypothesis is normally a tentative conjecture, a tentative assumption. It should be proven right or wrong at the end of the research. If you have followed all these steps, at this point, you will be able to make a conclusion that will either prove right or wrong the hypothesis that you have formulated. Because we usually have a null hypothesis and a fundamental hypothesis. So it is either we take one and reject the other. If you accept the null hypothesis, you will always reject the alternative hypothesis. But if you accept the alternative hypothesis, you have to reject the null hypothesis. This can only be possible after you have carried out, you have designed and conducted the study, and you have followed the statistical analysis, and then you compare your value with the value you have on the standard table of values. Then you'll be able to make your conclusion. You'll be able to make your conclusion. All right. So now we want to look at the method of formulating a hypothesis. All right. So hypothesis is a prediction, assumption, or what we can say a testable prediction or testable assumption. That after your test, you now know which one is right or wrong. Okay. Now, that is why they refer to hypothesis as a thesis statement. Thesis statement. All right. When you make such a statement, it is expressed as in a scientific manner. They will say you theorized or you hypothesized. Theorize, hypothesize, or you posited. That is in the assumption of hypothesis. So your statistical analysis will now help you to make the right conclusion about the hypothesis you made. This is what I mean now. Let us say somebody is testing. This is just an example. It's not a real situation. Somebody is testing whether elements such as rainfall, sun, can affect cement, concrete that is exposed outside. So such a person, we have to assume that it affects or not, it does not affect. So that is what we talk about. You hypothesized by taking measurements, values. Then you hypothesize, you make an assumption that sunlight energy or rainfall or this can affect. That's an assumption. But when you carry out your analysis, you reach a conclusion. You now know whether your assumption is right or wrong. So you now finally make a conclusion by reporting the results that you have. All right. Now we have the following steps that are necessary procedure in setting up a research hypothesis. Okay. So we have simple procedure. All right, I can see that we have about 7 people connected now. So invite others to come and join, and then let the rep take note of attendance of people joining. Invite them to come, share the link to them. Now, these are the steps that we follow in formulating hypothesis. Okay. Number 1, we have null hypothesis and then fundamental hypothesis. Like I mentioned, there must be null hypothesis and at least one fundamental hypothesis. So null hypothesis is represented as H0. This is called null hypothesis. And then H1, fundamental hypothesis. We can have more than one fundamental hypothesis, but there must be one at least. So there must be one null hypothesis. There are usually one null hypothesis. And then there must be one fundamental hypothesis. There can be more than one. You can have H2, H3, depending on the type of research you are actually working on. Depending on the type of research you are working on. We can have H3, we can have more than that as well, depending on the type of research. But usually, whatever the case, you must have two hypotheses at least. That is null hypothesis and then fundamental hypothesis. Okay. Now, the null hypothesis is a hypothesis that does not see any effects between variables. The null hypothesis assumes that there is no impact between one variable on another, that there is no influence of one variable over the other. That is null hypothesis. That is null hypothesis. It assumes that there is no impact, no significant impact between one variable and the other. So it is just there. The variable does not affect each other. There's no effect. For example, somebody may be testing the reason why students perform poorly in exams over the years, and is assuming that economic reasons are responsible. For example, when students are from poor background, that can affect their performance in academics. Now, generally speaking, you may want to assume that it's true. The economic background of individuals might have an impact on their performance in higher institutions. But when you are formulating a hypothesis, the null hypothesis assumes that that is not true, that their background does not have any influence on their performance. That is what null hypothesis always, states. You always write your null hypothesis to say that there is no influence, there is no impact between one variable and the other. So there is no effect between this set of variable over the other set of variable. That is what null hypothesis always states. That is the number one here, H0. Now for alternative hypothesis is what you are really interested in finding. So when you are formulating your hypothesis, you must realize that alternative hypothesis will be the part that you are interested in this research. That is, you believe there's an impact or effect between this set of variables and this set of variables. So you will write your hypothesis to show that there is an impact in the alternative hypothesis. You put that statement under alternative hypothesis. So take note. The alternative hypothesis is the one that says there's an influence or an effect between this variable and the other. Are we together? That is what you will do. Null hypothesis does not see any effect, any influence, any impact between one variable and the other. But alternative hypothesis says there must be an impact, that this variable is affecting the other. So for example, we talk about the example I gave just now regarding the economic background of students. So that students that have so amount of money, that having background of so amount of money, they are performing poorly because they don't have money. That is alternative hypothesis. That's what you will state in your alternative hypothesis. Your null hypothesis will say there's no such thing. Their background in terms of economic background does not have any impact on their performance at school. So that is how we formulate hypotheses. I believe you guys can hear me clearly. If so let's go ahead to type yes on the screen. If you can hear me clearly in this live class, just type yes on the screen. All right. So let's move on. So the alternative hypothesis is what you are really interested in the research. What you believe should be the reality in the research. Even though you are still assuming, but you must assume because you are actually carrying out your research. So you must assume that there's an influence between this variable and the other. And that assumption is a statement that you put in fundamental hypothesis. Null hypothesis say there is no influence between one variable and the other. There's no impact at all. no effect whatsoever between a set of variable and another set of variable. So that is the way we formulate our hypothesis. So we make the thing we are trying to show to be true to be the alternative hypothesis. Alright? Now, when we find evidence in the analysis in the inferential statistics that we carry out, then we come back to either accept this or this. For instance, if after your analysis you find out that really the effect is not significant, then you will reject the alternative hypothesis and accept the fundamental, the null hypothesis. You accept the null hypothesis and reject the fundamental hypothesis. But when after your analysis, you find out that truly speaking, there's an inference between one variable and the other. So in your conclusion, you come and say null hypothesis is not true, so we reject it and accept the fundamental hypothesis. That is the procedure for carrying out research using inferential statistics. So the inference that you make from your statistical analysis will be the one to direct you to either accept or reject either of these two. All right. Now, you must make sure that you clearly understand the hypothesis when you are formulating it. You must be very, very sure. You must make it clear, and then do not assume that the reader will understand what you are writing. No, you have to write it clearly. Present it clearly. In the research. All right. Then also, you must also bear in mind that when you are performing a research, over the course of the research, the hypothesis may actually change. You may have to come back and reformulate your hypothesis. You may have to reformulate your hypothesis. Now, we want to talk about significant level. Significant level. I mentioned this earlier. Significant level is the alpha. Alpha is represented as alpha, and alpha can be 1%. That is 0.1. It can be 5%. Sorry, this is 0.01. This is 0.05, and it can be 10%, and that is 0.1. Now, usually we use 5% in most research. Now, what is the meaning of all this? It means that if you use 1%, if you perform this research over and over again, 100 times, then 99% of the time you get the same results. And the 1% that you didn't get the same results is due to circumstances beyond your control. Experimental errors and things like that. So, but practically, if you do it 100 times, 99%, the answer will still remain what you have obtained. So you use 0.1, that is 1%. Now, if you say 5%, it means 95% of time, if you repeat this procedure 100 times, 95% of time will still turn and produce the same results. And 5% is due to some experimental error or circumstance not within your control. And likewise, 10%. 90% will be true and 10% will be untrue. But usually we use 0.05, that is 5%. So if you are given a question to actually handle using inferential statistics, you will use 5% if you are not told otherwise. Except you are told to use 1% or whatever percentage, and then you go ahead and use 5%. All right. Then we talk about degree of freedom. Degree of freedom means the number of observations that are allowed to vary in a particular research data. All right. The number of observations which are free to vary when certain restrictions are being placed on the data being considered. Now let's look at an example on hypothesis. Let's look at an example. All right. Let us say we want to test whether the mean score of an exam is greater than 80. Mean score in an exam, we want to test whether it is greater than 80. So in this case, we are talking of average score of students in an exam. In this case, we are interested in the fact that that average will be, greater than 80. To be greater than 80, that's what we assume should happen. So that interest of ours in this particular research will be the alternative hypothesis. Now, you have to take note that when you are formulating hypothesis, your H0 and H1, they must be all encompassing. They must cover all available options. They must not leave out any, portion. So in this current example, I state that we want to know whether the mean score of an exam is greater than 80. And I said that will be stated in the alternative hypothesis, H1. Then H0 will be the remaining parts that H1 has not covered. So to write that, we will put it this way. Let us represent the mean as mu. So H0 mu less or equal to 80. H1 mu greater than 80. That is the statement we have to write. So we have formulated a hypothesis for that particular situation. The situation says that the mean score is greater than 80. That is what we are interested in. So we put it in the alternative hypothesis, H1. So any available option apart from this will now be stated in the null hypothesis. That is why our null hypothesis says less or equal to 80. That means 80 is inclusive. Then from 0 to 79 also inclusive. So you can see that these two statements, as taking care of all available scores in this particular situation. If the score is based on 100, so we are saying that greater than 80, from 81 to 100, or even 8.1 to 100, is our assumption that performance should be high, so that average is above 80. Now, the null hypothesis will now take care of remaining available options, which will be from 0 to 80, and that is what this one is taking care of, mu less than or equal to 80. I hope you understand this. If you do, just type yes on the screen. Type yes on the screen. And don't forget to like and share the video. Share it out so that others can join us in this class. So don't forget to put down your registration number on the screen so that it can be recorded for you as attendance. So someone is taking care of the attendance, the class rep is taking care of the attendance, and is going to be written down and submitted later. So just follow along. I can see your yes. I can see you are typing yes. All right, let's formulate another hypothesis. Let's use another example. Now, to test that the mean delivery time for a meat pie processing eatery is less than 15 minutes. Is less than 15 minutes. That is what we are interested in. That the delivery time should be less than 15 minutes. So to write the hypothesis, this is what we are going to have. We are going to have H0 to less than 15 minutes will be the alternative hypothesis. Mean is greater or equal to 15. And H1 mu less than 15. That is in minutes now. And that is how we are going to write it. So we are formulating this hypothesis that the mean delivery time of a meat pie processing is less than 15 minutes. Less than will be in the alternative. Because that is what we are really interested in this test, in this research. And greater than, or equal to 15 will be in the null hypothesis. I hope this is very clear. So when you are formulating your own, take notes. Alternative hypothesis is what you are really interested in the research, what you are really testing for. And the null hypothesis is all available options. And usually, null hypothesis, if you are considering matters that involve making a statement, null hypothesis tells you that there is no impact or influence, significant influence between one variable and another. That is the assumption of null hypothesis. For your alternative hypothesis, we say otherwise, that there should be an influence between this particular variable and the other. All right. Let's look at another example. Now, annual salary, annual pay for doctors. To show that annual pay for doctor is not 50 million naira. That's the annual pay for doctor. The mean annual pay for doctors differs from 50 million naira. How do we want to write that? Differs from 50 million naira. Okay, so we are going to write the hypothesis this way. H naught mu equals to 50. What we are interested in is it differs. That would be in the alternative hypothesis H1. So mu not equal to 50. And this 50 is not ordinary 50. We are talking about 50 million. So you can put the other 00 or you put times 10 raised to power 6. It's not ordinary 50. Times 10 raised to power 6. That's 50 million. You can put it there or you put the zeros after it. So the null hypothesis mu equals 50. Alternative mu not equal to 50. This one is not equal to now. It's not less than, it's not greater than, but we are saying not equal to 50. And that is how to formulate the hypothesis. Now in each case, you will realize that these three examples, you will see that the statements H0 and H1, they are complement of each other. They complement each other to cover all available options so that none is left out. If you leave anyone out, then your research will be wrong. Your inference will be wrong. So you must make sure that your set of hypotheses are formulated in an all-encompassing way to cover all available, conditions. I hope that is very clear. All right. Now, last time we talked about inferential statistics. We made mention of inferential statistics. And today also we have made mention of it that when you have formulated a hypothesis and you set up the research design, then you will look for a particular statistical test to test the hypothesis. And this usually we use inferential statistics. We use inferential statistics. Okay. All right. So what do we mean by inferential statistics? Those are statistical methods that are used to analyze the data you have, the quantitative data, to now compare one variable against the other and show whether there's any significant effects, significant influence between one variable and the other. Okay, so that is inferential statistics, and we have several examples of inferential statistics. So today, these inferential statistics, we normally call them test statistics. We have several of them, and today we are going to take only one, to demonstrate. So let's look at a chi-square test. Chi-square test. And we're going to take like I'm very sorry, the network is fading. It has been reconnected. The network is back. If you can hear me, please type yes on the screen. If you can hear me, please type yes on the screen. If you can hear me, please type yes. It's important so that I can continue. It's important if you can hear me. All right, I have 12 people connected right now, and I want to know. So, okay, type yes. Okay, I can see your yes. I can see your yes. Let the rep take note of the attendance as is being typed onto the screen. Take note of the attendance, the registration number as it's being typed onto the screen. All right, so you can hear me. We continue. We want to take example of inferential statistics. So the test statistics that we are taking to is the chi-squared method. We are going to use chi-squared method today. We are going to learn about how to use chi-square to make an inference in the research data. That's what we are doing today. Now, in the chi-square method, we are going to use an example to demonstrate how to do this, and that will be we're going to use a 2x2 contingency table. 2x2 contingency table. Okay. Now let me show you what the table looks like. We have data type, question type, and possible responses. Data type, and then question type, and the possible references. Possible reference, possible responses, possible responses. This will be formulated into a table, okay, for the 2x2 contingency table. Now, when you formulate the table, then you'll be able to bring out the data there and apply the chi-square method in it. Now, let me show you the 2x2 contingency table directly. The 2x2 contingency table, we have variable 2. Let's draw the table. Okay. We have this table like this. In this table, we are going to show what will be in each of those boxes, like the 6 boxes that we have now. We should have 8 boxes, not 6. We should have 8. And then also here, because we are going to have the total. We're going to have the total. So as it is now, we have variables and we have categories. Okay. Now this side now is for one variable, variable 1, and this side down is for variable 2. Now, having got that, we now have category 1 and category 2. Category 1, category 2, we have the total, which we are going to see soon. Then we have data type 1, data type 1, data type 2, data type 2. Okay? Then we have total on this side also. Now we now have the variables and data. We have A, that would be a number, B, another number, C, and then D. Now this is the 2x2 contingency table. So in a particular test, in a particular question, to use chi-square, what you are given is this 4. They give you the data type and the category, and they give you this 4. So this column is not there, and this row is not there. But what you need to perform when you have the table, you need to perform this, add this column and add this row. So here to here, then you do summation. A plus C, B plus D. Then you add like this also across, the row. A plus B and C plus D. The total here will now be the summation of everything, which is equal to N. A plus B plus C plus D, which is equal to N. That's the total number. And this is the 2x2 contingency table. So this is what you perform. You perform this, perform this, perform this, perform this, and perform this one also. Then you need those figures in the formula. And the formula is given like this. X squared This x squared represents the chi-squared. It's a symbol. It is not actually x, it's a Greek letter, but since it looks like the English letter x, so we call it x squared. It's not really x, but for you to write it, you can write it as x, okay? Now, AD minus BC, this equals to AD, this times this, minus this times this. AD minus CD squared. Take note, squared. Multiply by A plus B plus C plus D. That is this. Divided by this, multiply by this, multiply by this, multiply by this. That is A plus B, multiply by C plus D, multiply by A plus C, multiply by B plus D. So you can see how we obtain this formula now. All of them are coming from this table. So you perform this, perform this, perform this, perform this. Out of 1, 2, 3, 4, you are given in the A, B, C, D. So you perform the other parts, and the other parts will help you to use this chi-square formula. And that's what we have there. So the formula goes this way. Chi-square equals AD minus CB. This is CB. CB minus CB all squared multiplied by A plus B plus C plus D. That is this. Divided by A plus B multiplied by C plus D multiplied by A plus C multiplied by B plus D. So all those, they are numbers that you must have obtained when you are given the problem, because the problem comes as a value. Rather than A, B, C, D, you have values in the 2 by 2 contingency table. Now, with this, you will now look for degree of freedom. Degree of freedom. You need degree of freedom, and degree of freedom is the rows and columns. The rows and columns, we determine degree of freedom by rows minus 1, column minus 1. That is R minus 1 multiplied by column minus 1. Number of rows and number of columns minus 1. So you multiply them together. So we have 2 rows, 1, 2, and 2 columns. Sorry, two rows, 1, 2, and 2 columns, 1, 2. So for this particular 2 by 2 contingency table, it will be 2 minus 1 multiplied by 2 minus 1. You can have more than maybe 2 columns or 2 rows. It's possible, depending on the type of research you are carrying out. So I want to use a particular question as an example to demonstrate this particular chi-square. So, so we are given a problem. Suppose you are conducting a drug trial on group of animals, and it is hypothesized that the animals receiving this drug will show increased heart rates. Take note. Animals will show increased heart rates compared to those that did not receive the drug. So you conduct the study, and then you have a table of data. At the table of data given. Okay, let me modify this particular table to form it, or probably rub it off outrightly. So let's leave the formula down there. So we form the table. The table you are given is 3 first. Before you increase it, you have it 3, 3, 3. Now we have treated here. We have non-treated here, meaning that the animal that are treated with the new medication and the animal that are not treated with new medication. Now here we have the heart rate increased. Heart rate increased. Then the last one, no heart rate increase. No heart rate increase. So they are now giving values 36, 14, 30, and then 25. So with that, we are going to go ahead and perform the chi-square test. So you need to construct the last row and column in solving the problem. So you have to construct the last row and column. So with that one, then you'll be able to do the totals. Total here, total here. Then it is after performing that, you fill up all these spaces according to the previous table given. Then you employ this formula to solve it. All right, so what we want to do now is to form total and total here. So sum this up, you put the value here. Sum this up and put the value here. If you sum this up, we have 50, this one 55, if you are following. And then here we have 66, and here we have 39. The total sum of everything, you add this up to get it here, or you add this up to get it here. So we have 105. That's the total sum of everything. I believe you are following. If you are following, just type yes on the screen. All right. Okay. So we want to now use the formula whether there is an influence of the medication on the animals, whether the animal are experiencing increased heart rate due to the treatment given. That's what we are doing. That's what the research is trying to, find out. So using this formula, we can substitute these values into the equation there and simplify it. All right. So this summation is 105. So this can be AD minus CB. AD, that is 36 minus 25. 36 minus 25. This times this minus this times this 30 times 14. You now square this. That is square on top of it. Multiply by summation of everything, which is 105 times 105. Then you divide all by summation of all these, A plus B. Okay? That's 50. C plus D. That's 55. A plus C. That is 66. And then B plus D. That's 39. Now, if you calculate this carefully, what you will get is 3.418. 3.418. You can cross-check using your own calculator. Using your calculator, 3.418. And this is the chi-square value that we calculated, 3.418. For the 2x2 contingency table, 3.418. Now, having got that, we need to now use it to make a conclusion by checking the statistical table. We need to check the statistical table to determine whether our assumption is right or wrong. Now, before everything, we need to actually, formulate hypothesis. Before you solve the problem this way, you must formulate hypothesis. How do we formulate hypothesis in this case? Now, you formulate null hypothesis. And null hypothesis, that I have explained to you, says there is no impact from one variable to the other, over one variable from the other. All right. So we can say, heart rate is not due to treatment. That is a null hypothesis. Alternative hypothesis is now what we are really interested in, that the treatment is affecting the heart rate of animals. So we can make a statement that heart rates increased Okay, increase, there should be increase here. Increase, heart rate increase is due to the treatment applied. So you can make your statement in another way, just write it to make sense, to conform to the law, to show that what we're interested in is in the alternative hypothesis, and the null hypothesis is supposing that there's no impact between one variable and the other. So having made these statements, we want to test the chi-square value with the standard values for research. Now what we do is now to go to the chi-square table. You go to chi-square table to go and check for this particular experiment, for this particular test, whether the value we obtain based on 5% alpha, 0.05, 5%, that what we get here is significant, whether it is too low or too high. So when we compare this with what is on the table, then we make a conclusion. Alright, so when we go to the table, if you open your statistical table under chi-square test, when you get there, you look for the 5%. 5%. This is 5%. Then you now check for degree of freedom. In this case, degree of freedom is 2 minus 1 times 2 minus 1. That is row minus 1 times column minus 1. 2 minus 1 times 2 minus 1 is equal to 1. So if you go to the chi-square table, you go to under 5% table, chi-square 5%, okay? Then you go to degree of freedom 1. You see degree of freedom written there. So you check the column and the row where they meet, then you pick the value. So if you do that, this is what you are going to get. You are going to obtain the chi-square lying in between 2.706 and 3.841. In actuality, what you see is about 3.8 something, 3.8 something, 84 something. So I don't have the table directly here, but it's going to give us the table value. Chi-square table value about 3.84 something, which is higher than what we have calculated. It's higher than what we have calculated. So for that reason, we want to make a conclusion. Now it is the p-value of what we calculated is greater than what we have at sorry, this is supposed to be probably 3.148 or something. 3.148 or something. So the point is the p-value of this, of what we calculated, is higher than what we find on the table. The tabulated value is less than what we calculated. The p-value is at 5%. So for that reason, we accept the null hypothesis. We accept the null hypothesis and we reject the fundamental hypothesis. And the null hypothesis says the heart rate increase is not due to the treatment. It's not due to the treatment, okay? Treatment. It's not due to the drug treatment. That is to say, the heart rate of animal, does not increase based on the new medication applied to them, to the animals. So in essence, we are rejecting fundamental hypothesis and accepting null hypothesis. And that's it. We are accepting null hypothesis and rejecting fundamental hypothesis. So by this conclusion, you now see that the researcher can now make his statement, can now make his conclusion, and tell the person that is bringing the drug for the animal, that the drug does not actually negatively affect the heart rate of animals. That even animals that were not treated, if you look at that table, animals that were not treated, some of them also have heart rate increase. So it can conveniently say the heart rate increase that we observed here is not due to the drugs that have been administered on the animals. And that's the final conclusion. So you can now see how to test the hypothesis. We have just tested the hypothesis, these two hypotheses now, based on the data we have using chi-squared method. So chi-squared method can be used to test two variables, or sometimes when you have more than two, when you have data of more than two variables, you can use chi-square to test. And that is the way of scientific research. You choose a particular test statistic that is applicable to the set of data that you have, and you carry out the statistical analysis and draw a conclusion based on what you have on the standard table of values, like the one we have here, compared to what you have calculated. So whatever you have in the standard table of values will help you to make a conclusion on the set of data that you have tested. So I hope you got this example well. So I believe you understood this very well. And I don't know whether you have any question on what we have, carried out, the example we have taken here. All right. If you look at the board, because of the network, the board is still clear. I don't know what happened at your end. Somebody is saying the board is not clear. The screen is blurred. It's because of the network. What just happened recently when the network went off and it reconnected? That's what happened. Initially, it wasn't like this. But I believe that you have grasped what we are saying, and later on you will see this video, on the channel. Just try to watch it again so that you can learn and compare to your handouts, so that you can learn more about the application of chi-square as a test statistics in research. So if you don't have any question, gradually we are coming to the conclusion of this class. All right, so you have the video later on the channel so that you can see it clearly, and then you learn more about it. So I say thanks for coming, and don't forget to put down your registration number, and the class representative will actually take down the attendance. So that's what we have today. Thanks for coming. Don't forget to click like and share the video, and then another time when it is time to give a live lecture, we'll see meet there once again. So thank you very much for joining the class. So in a short while now, I'm going to end the class. So put down your registration number for the representative to take note of it. The representative should take note of the registration number. It's important. So that's that. We are ending this class right here today. Until another time, I say bye-bye.